But the problem is that we got the latest image and it looks like a single object in the middle. So we don't know what is going on.
The 12th anomaly has just dropped, and this one breaks everything we thought we understood. New observations of 3I Atlas reveal jets that stay perfectly aligned even as the object rotates, a behavior that shouldn't happen under any known physics. It's a discovery forcing astronomers to rethink the fundamentals of outgassing, motion, and cometary mechanics. If you're ready to dig into what this could mean and why scientists are so divided, make sure to subscribe and leave a comment with your thoughts. Let's get into it.
The new images of 3I Atlas seem to show the tail is back. What is the significance? What do you make of this?
Well, actually, we don't just see a tail. In the latest images, we see all the 7 jets coming from the central object.
The latest observations have left the scientific community scrambling for explanations. Multiple telescopes tracking the object designated 3I Atlas captured something extraordinary throughout November. Gas and dust jets erupting from its surface extend more than 1 million kilometers into space, roughly 3 times the distance between Earth and the Moon. Material races outward at velocities approaching 400 meters per second. Yet despite this violent activity, the jets maintain razor-sharp alignment across multiple observation sessions spanning days. Here's why that's baffling. The object completes one full rotation every about 16 hours. As it spins, different regions of its surface should face the sun, heat up, and vent material in constantly changing directions. Every comet ever studied shows this pattern. Jets trace spiraling or fan-shaped trajectories as the nucleus tumbles through space, creating broad smears of gas and dust. It's basic rotational mechanics, as fundamental as a spinning sprinkler arm spreading water in circles. 3I Atlas ignores these rules entirely. Its jets remain columnated and directionally stable as though somehow compensating for the object's rotation in real time. Imagine a garden hose spinning wildly yet keeping its stream perfectly straight. The precision borders on paradoxical. For this level of stability to occur naturally would require mechanisms never before identified in any celestial body. The observation marks the 12th major anomaly associated with this object, but this one eclipses all previous mysteries and its implications for physics. Before the jet alignment puzzle emerged, 3I Atlas was already defying expectations in other ways. The object has brightened at a rate faster than any comet in modern astronomical records. Observers tracking its luminosity noted changes that suggested massive outgassing events, yet something didn't add up. Calculations indicated the object would need to lose approximately 13% of its total mass to account for the brightness increase and the non-gravitational acceleration detected in its trajectory. The problem? No corresponding debris cloud appeared. When comets shed that much material, they leave visible trails of dust and fragments. Telescopes scanning the area around 3I Atlas found none of the expected evidence. Even stranger, the object underwent a dramatic color transformation. Early observations showed a reddish hue consistent with organic compounds or weathered ice. Then it shifted to a deep blue, the opposite direction from normal cometary evolution. As comets age and lose volatile materials, they typically become redder, not bluer. Polarization measurements added another layer of mystery. Light reflected from 3I Atlas showed extreme negative polarization values, unprecedented in any known comet. These optical properties don't match anything in the existing catalog of solar system objects. Each measurement seemed to place the object further outside the boundaries of understood cometary behavior, suggesting either exotic composition or processes astronomers haven't encountered before. October 29, 2025 marked a critical moment in the object's journey. On that date, 3I Atlas reached perihelion, its closest approach to the Sun. This period typically offers the best opportunity to study interstellar visitors, as solar heating triggers maximum activity and reveals compositional details through spectroscopic analysis. But 3I Atlas passed through this window positioned behind the Sun from Earth's perspective, making direct observation extremely difficult. The timing sparked considerable public discussion. NASA's imaging schedule and the release of observational data became topics of scrutiny on social media platforms. A government shutdown coinciding with the observation window further complicated matters, leading to questions about whether adequate resources were allocated to tracking such a rare visitor. Congressional representatives, including Congresswoman Anna Paulina Luna, made public inquiries about the observation protocols and data availability. The situation highlighted the challenges inherent in studying objects with trajectories that don't align with optimal viewing conditions. Unlike scheduled satellite launches or predictable eclipses, interstellar objects arrive on their own timetables. Whether human observation infrastructure is positioned correctly becomes a matter of cosmic chance. The perihelion pass remains a gap in the observational record, a moment when the object was most active but least visible. The coming months represent humanity's final opportunity to gather data before 3I Atlas exits the solar system forever. December 19, 2025 marks the closest approach to Earth, though at 240 million kilometers, roughly the distance between Earth and Mars, it remains far beyond any hope of in-person investigation. However, this geometry provides the best viewing angle for ground-based telescopes in the Northern Hemisphere. March 2026 brings another crucial window. As 3I Atlas passes near Jupiter, NASA's Juno spacecraft will be positioned to capture observations from a different perspective. The European Space Agency's JUICE spacecraft, currently in transit to Jupiter, may also contribute data depending on its exact position and operational status. These space-based assets offer viewing angles and instruments unavailable to Earth-based facilities, potentially revealing details obscured by atmospheric interference or distance. Researchers have outlined specific observations that could resolve current mysteries. High-resolution spectroscopic analysis could identify the chemical composition of the jets, distinguishing between water vapor, carbon dioxide, or more exotic volatiles. Radio telescopes are monitoring for any coherent emission patterns, though none have been detected so far. Teams are also building more sophisticated rotation models, attempting to reconcile the stable jet orientation with angular momentum conservation. Each dataset narrows the possibilities. Scientists hope upcoming observations will either reveal a natural mechanism that explains the behavior or provide evidence so anomalous it demands entirely new theoretical frameworks. After March, the object will be too distant and dim for meaningful study, disappearing into the darkness between stars with its secrets intact or revealed. Long before the jet alignment mystery emerged, 3I Atlas was accumulating a record of unusual characteristics. Early observations detected a sunward jet, sometimes called an anti-tail, pointing toward the sun rather than away from it. While not impossible in cometary physics, such configurations are rare and suggest complex subsurface activity or unusual surface geometry. Trajectory analysis revealed another statistical oddity. The object's path through the solar system aligned closely with the ecliptic plane, the imaginary disk where most planets orbit. Researchers calculated this alignment as having only a 0.2% probability of occurring by chance for a true interstellar visitor. Most objects arriving from random directions in the galaxy would cross the solar system at much steeper angles. Size estimates added to the puzzle. With a mass calculated at roughly 1 million times that of Oumuamua, the first confirmed interstellar object, 3I Atlas represented something fundamentally different in scale. It was moving faster than typical interstellar objects, suggesting either a different origin point or acceleration mechanisms not immediately apparent. One curious detail caught attention among researchers familiar with radio astronomy history. The object's direction of arrival placed it within 9 degrees of the coordinates associated with the famous WOW signal, detected in 1977, though scientists emphasize this is likely coincidental, given the vast number of directions in space. Each new measurement seemed to place 3I Atlas further from the template of known comets. By the time the 12th anomaly emerged, the object had established itself as the most enigmatic interstellar visitor yet recorded. The story began on July 1, 2025, when the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, detected an unusual object from its facility in Chile. Initial trajectory calculations immediately flagged it as extraordinary. The object followed a hyperbolic path, meaning it possessed enough velocity to escape the sun's gravitational pull. It wasn't bound to our solar system. It came from somewhere else. This marked only the 3rd time in history that astronomers had confirmed an interstellar object passing through our neighborhood. The first, Oumuamua, arrived in 2017 and sparked years of debate with its cigar-like shape and unexplained acceleration. The second, Comet Borisov, visited in 2019 and behaved much more like a conventional comet, easing some of the tensions from Oumuamua's strangeness. Now, 3I Atlas represented a 3rd data point, and early indications suggested it would be anything but ordinary. The designation 3I Atlas follows astronomical naming conventions. The 3I indicates it's the 3rd confirmed interstellar object, while Atlas credits the discovering telescope system. Preliminary velocity measurements showed it moving at speeds consistent with an origin outside our solar system, confirmed by calculating its trajectory backward through space. Unlike asteroids or comets native to our system, which follow elliptical orbits around the Sun, 3I Atlas was just passing through, a traveler from the void between stars. From those first observations, astronomers knew they were witnessing something rare. The challenge would be gathering as much data as possible before it vanished forever, a task made more urgent as the anomalies began revealing themselves. As the list of unexplained behaviors grew, some researchers began exploring hypotheses outside conventional cometary science. Astrophysicist Avi Loeb, known for his willingness to consider unconventional explanations, has proposed that the jet alignment behavior could resemble characteristics of controlled propulsion systems. The precision with which the jets maintain orientation despite rotation, he suggests, might indicate active stabilization rather than passive venting. Loeb introduced a conceptual framework he calls the Loeb scale, designed to quantify how far an observation deviates from natural expectations. The scale ranks anomalies from 1 to 10, with lower numbers representing unusual but explainable phenomena, and higher numbers indicating departures so extreme they approach what might be expected from technological objects. By this metric, 3I Atlas currently ranks around level 4, firmly in anomalous territory but not yet reaching the threshold where natural explanations become impossible. Proponents of this line of inquiry draw parallels to the earlier Oumuamua debates, where similar questions about unexplained acceleration sparked controversy. They argue the precision of the jet alignment warrants serious consideration of all possibilities, including mechanisms that might involve deliberate control. The hypothesis doesn't claim alien origin, but rather suggests keeping the inquiry open until data definitively close off certain possibilities. Critics emphasize that extraordinary claims require extraordinary evidence, and current observations, while puzzling, haven't crossed that threshold. The speculation represents one hypothesis among several being explored, not a conclusion drawn from data. The majority of planetary scientists maintain that natural explanations, however exotic, remain far more plausible than invoking technology. Several researchers have proposed mechanisms that might account for the stable jet orientation without requiring active control. Complex surface topography, including deep canyons or cliff faces, could potentially channel outgassing into narrow streams that maintain coherence longer than expected. Some scientists suggest the alignment might result from viewing geometry, where the rotation axis happens to align with our line of sight, creating an illusion of stability. Others propose exotic ice compositions or layered crusts that could redirect sublimation in unexpected ways. These explanations require stretching conventional models, but they remain within the boundaries of known physics. Professor Jason Wright, among others working on alternative natural mechanisms, has emphasized that unusual doesn't mean artificial. The history of astronomy includes many observations that initially seemed inexplicable but ultimately yielded to natural explanations once better data arrived. The challenge lies in distinguishing between genuinely unprecedented phenomena and gaps in observational coverage or theoretical modeling. The debate has also touched on scientific methodology. Some researchers argue that prematurely entertaining speculative hypotheses risks credibility and distracts from gathering quality data. Others counter that dismissing possibilities too quickly can lead to missed discoveries. The tension reflects broader questions about how science should handle observations that fall outside established categories. Data from upcoming observations may resolve some disagreements, but the scientific process requires patience. Multiple competing hypotheses remain under active investigation, with researchers on all sides emphasizing the need for reproducible evidence before drawing firm conclusions. Whether 3I Atlas ultimately reveals exotic natural physics or something more unprecedented, it has already reshaped how astronomers think about interstellar visitors. The object has demonstrated behaviors not seen in any previously studied comet, pushing the boundaries of current models and forcing researchers to consider mechanisms they hadn't anticipated. The coming months will provide crucial data that could resolve these mysteries or deepen them further. The universe continues presenting phenomena that challenge human understanding. Each interstellar visitor offers a glimpse into environments and processes beyond our solar system, expanding the catalog of what's possible in cosmic mechanics. Regardless of the final explanation, 3I Atlas has advanced the field simply by existing and behaving so unexpectedly. As observations continue and models evolve, the scientific community remains focused on letting evidence guide conclusions. The object serves as a reminder that space still holds surprises, and the work of understanding them requires both imagination and rigor. If you found this fascinating, subscribe for more deep dives into astronomy's biggest mysteries, and drop a comment with your thoughts on what 3i Atlas might be. Thanks for watching, and I'll see you in the next video.